Hi, everyone. This afternoon, I'm pleased to introduce Associate Professor Abdel Fattah from University of Tromsø, Arctic University, together with Regina Hauk from the University of Oslo. They will present some social and political perspective on cryosphere hazard under climate change. So the session will have different speakers, and there will be Q&A at different points of the session. So you're welcome to ask questions if you want. Please, now the floor is yours. Thank you.
Hey, good afternoon, everyone. As mentioned, my name is Dina Abdel Fattah, and I'm an associate professor at UiT, the Arctic University of Norway. And today we will be speaking about cryospheric hazards under climate change. So the topic is looking at the science policy perspective of how we can look at our information, our understanding of a changing cryosphere, and how that impacts communities and ultimately society around the world. We have a very interesting event scheduled for today. So we have different sections set up. We'll be looking first and foremost at what is a cryospheric hazard. So my colleague, Dr. Hauk from University of Oslo, will give us a background on this topic from a science perspective. So we can kind of go into this from an informed understanding of what a cryospheric hazard is. We also will be looking then at sea ice hazards, and we'll be taking Alaska as a backdrop throughout this whole session. So we'll be looking at case studies and different types of hazards, and also the ways that community members and agencies and so forth have adapted to and respond to these hazards in Alaska. After looking at sea ice hazards, then we're going to be looking at glacial lake outburst floods, another type of cryospheric hazard that is common in Alaska and other parts of the world as well. So we'll be getting an agency perspective to start off by Jessie Cherry. She's a NOAA agency a specialist in Alaska, and she'll be giving us then the perspective of what it means from a US governmental perspective to work with these types of emergency management responses. I'll also be giving some background on societal impacts of GWAFs, as we will abbreviate in this session, in Alaska. And we'll also be having a virtual contribution by Dr. Aaron Hood from the University of Alaska Southeast about the glacial lake outburst floods that happened then in Juneau, and one that was very notable this past summer. And then lastly, I'll close in with a few remarks about the role of science communication in policy and what we can expect moving forward as these types of hazards change, as well as our cryosphere changes in the years to come. So as you see, we have multiple points for Q&A. We look forward then to hearing from you. And if at any point you have any questions, just reach out over the chat as well for those that are online. Yes. I also wanted to highlight, as I mentioned, the two case studies. For the sea ice hazards, we'll be looking at Utqiagvik, which is the most northern point in Alaska, so naturally where a lot of the sea ice hazards take place, and also in Juneau, Alaska, where our GWAFs tend to happen in Alaska as well, too, among other places as well. So then I will hand over then the session to Dr. Regina Hauk to talk about the science behind cryospheric hazards. Okay, thank you very much. I'm still waiting for the presentation. So I will be focusing on glacial hazards. Yeah. Okay, thank you. So glaciers are losing mass and retreating worldwide. Here's two examples here from Alaska and Switzerland. And on a global scale, the glacial mass loss rate is increasing. And at the moment, we have about 50 to 60 centimeters thinning every year, average over all glaciers in the world. And the projections show that this glacial mass loss continues. And we see that for every degree global temperature change, the mass loss and the area loss increases in a linear fashion here.
So for instance, 2 degrees, there's a 45% mass loss projected and a 35% area loss. So every single degree temperature increase matters and has a direct effect on the amount of mass loss that we can expect. So what are the hazards? Why does it matter? One thing why it matters is sea level rise. As you can see here from this figure, is that the sea level rise, you see the sea level rise projected until the end of 2100, and the glaciers play a major role. Part of it is ocean due to warming thermal expansion of the oceans, but the remainder of the sea level rise, about half of it, comes from the melt of ice. And some of it from Greenland, some of it from Antarctica. But what you can see is that the contribution of the glaciers in the very recent past was actually much larger than the one from Greenland and Antarctica, and it remains to be larger than the contribution from each Greenland or Antarctica. So what that means for hazards is, are there a 10, 20 centimeter increase in sea level rise might not sound very much, but what will happen is you have a higher risk for extreme sea level events through, for instance, stronger storm surges. And then there's an increased risk of floods, erosion, and you can have cascading effects that include then further coastal erosion or saltwater intrusions. When you compare it again here with the ice sheets, here are the projections from the IPCC report in 2019 for the low emission and the high emission scenario. And when you compare that to the contribution from the ice sheets, here the same level as the glaciers, you see actually from each the Antarctica and Greenland, the contribution of each of these ice sheets individually is less than the glacier contribution. But I must say, of course, this does not include any potential catastrophic or disintegration of the West Antarctic ice sheet. This can put it the sea level rise much higher from the Antarctic. But the glaciers do play a major role in sea level rise and the associated hazards like storm surges and coastal erosion. The glaciers retreat leads to changes in the stream flow. What we've seen is something missing. What we see is in regions, this is here from observations in Fernakfana and Austria, that during, you see in blue, the daily discharge, actually the hourly discharge here in the valley from the glacier during a period when the glacier was in balance. And you see just sort of 10, 20 years later, a period after a lot of retreat and negative mass balances, and you see the peak discharges are about 10 times as high as they were in the period before. And any infrastructure that was built during this period of balanced mass balances is then in danger. This is what happened here in 1998. A rainstorm combined with one of these high melt peaks washed away or seriously damaged here this research station. So there's a serious risk for floods as the melt increases and these daily, hourly discharge peaks increase. There's also there's also an impact on glacier outburst floods. Water can accumulate under the glacier, on the glacier, at the side of the glaciers, and that water can catastrophically drain and lead to outburst floods. And one mechanism is the glacier can be the dam. So water is dammed by the glacier, but with more meltwater and with glacier retreat, the water level can rise, and the dam is not strong enough to withhold that water. So when the ice pressure is less than the water pressure, then the water can catastrophically drain. And that is what we observe in many regions of the world, and there will be a talk later about this topic. Then lakes can also be dammed by moraines as the glacier retreats. And these moraine dams are not very consolidated, and they can easily be damaged and breached and lead to catastrophic outburst floods of these dammed lakes. And one example here is the most deadly flood observed here in India with more than 4,000 fatalities 10 years ago. Or another example in Peru, in the Cordillera Blanca in 1941, also several thousand fatalities when this lake here close to the glacier probably the flood was caused by an ice avalanche or a rock avalanche falling into the lake, overtopping the water, which then eroded that moraine dam and catastrophically flooded the town of Huaraz here in Peru. Glacier lakes grow because of the increased melt and the retreat of the glaciers. So here's a study showing that worldwide there's an increase in lake volume and area and number of lakes by about 50%. And this, of course, increases the risk of glacier outburst floods. But of course, it's not as simple that just an increase also leads to an increase in the flood risk, because in some other areas, as the glaciers retreat, there might not be any lakes anymore, and the risk can decrease. We also have seen in the past there's glacier collapses, and those events are very rare, and it's very hard to associate them yet to really our global warming. But what we know, these collapses can only occur if there's water at the bottom of the glacier. So there's a reduced friction that these glaciers can catastrophically collapse and form a huge avalanche. And of course, with more water, there's maybe a risk that these events can occur more often in the future. And this is here also here from this glacier collapse, just to give you an idea about the dimension of this event. And also several people died in this event. Another consequence that can happen is that actually the glacier retreat can lead to rivers being derooted due to deglaciarization. For instance, here there's an example in Yukon in Canada, where the Cryospheric glacier, when it was further advanced, the water was draining to the north. And then as the glacier retreated, it led to a glacier flood from this lake and a change in the geomorphology. And the glacier now is draining, the river is now flowing in the other direction. In this case, it had implications on that the lake level of the lake in the north was dropping suddenly, leading to some safety issues for boat launches. It also led to actually dust storms, creating some visibility problems along the major road along the lake. In other areas, this can also cause impacts on fishery, on water quality, water temperature, and so on. There's also another hazard that there is the release of anthropogenic legacy pollutants. There's a number of pollutants stored in glacier ice, and as the glaciers melt, these pollutants are released into the rivers. This can also then have possible impacts on water quality of down glacier streams and ecosystems. Another hazard is increased slope instability due to glacier retreat. As the glaciers thin, they expose more of the rock, of the steep slopes at the side. This combined with thawing permafrost has led and can lead to increased rock falls and landslides from these destabilized slopes. So just to wrap up here, the glacier retreat impacts hazards. There can be the impacts, the sea level contribution and associated storm surges, or floods due to more melt-induced water, but also floods due to glacier outburst floods, destabilization of mountain slopes, and the release of legacy contaminants stored in glaciers. But it's important really to note that the impacts vary regionally and on very small scales. In some cases, the glacier retreat can actually decrease the risk for hazards, but in others, it can dramatically increase the risk for hazards. And so it's really important to have the adaptation measures need to be adjusted locally. All right, thank you very much. I will do the presentation.
start with slide number 4. Yeah, okay, great. Well, thank you very much, Regina, for giving us the background then about the different types of glacial hazards we can expect under a changing climate. And the idea really is that, and I think Regina's point at the end, talking about that it's going to be so locally specific when we talk about these different types of hazards, because the context really matters in this case. So we try then from a policy perspective and from a science communication perspective to support then communities that are being affected by this on a very small granular scale. We have to understand then the underlying context of these areas and how these hazards are impacting the communities, what are the responses in place, and importantly, how do we then try to show the science in a way that people can understand it? Because not everyone in the audience is going to be a scientist. So we have to be able to communicate this in a way that people can uptake the information and use it to support their community needs. So as I mentioned, we'll be taking some case studies to kind of walk us through what I am trying to bring forth today in the presentation. And we'll take a step back from the glacier side just to kind of provide a different context about sea ice hazards. As we know, of course, the Arctic is warming very rapidly. So looking then at this high north perspective is important too when we talk about different types of cryospheric hazards. Excitement. Oh, sorry. Yeah. So sea ice hazards can look very differently depending on how they occur and how they then ultimately impact communities. First and foremost, we have what we call landmass breakouts events, where we actually have the ice detach from the shoreline and then actually go out to sea. So this can be a really dangerous scenario for those, for example, that do hunting on these as a platform. People have in the past and often find themselves out floating along with these breakout ice events. And this can be, of course, not only hazardous for those on the platform of the ice, but also for those trying to do an emergency response to help get them back to shore safely. We also have convergence events, which is then an opportunity then for the ice then to come together. And again, this can be really hazardous for those that are out at sea and also for those that are passing through on vessels and so forth. So often you think, oh, well, it's just in the ocean and 2 pieces of ice, they really can't be that dangerous. And it is. I mean, we've seen situations where, yeah, whole animals get crushed by these kind of incidents, vessels get crushed. So the sheer force of the ice, along with currents and movement of water, makes it extremely hazardous. And again, from an emergency response perspective, really puts at critical safety, especially if we're looking at the human life and safety perspective. And we also have what we call speed events, where we have drift ice, so ice that's already out at sea, getting caught in this drift essentially that then can collide with vessels and again cause really debilitating damage. So this is from the background perspective of why we're looking at this as a hazard, not only just to the ecosystems, but also to those that are operating in these environments. And Alaska provides a really unique opportunity to study this as a concept due to the community practices of whaling, other sorts of marine mammal hunting for the communities up north, and also just due to the sheer traffic of vessel activity and so forth. So the maritime community has been dealing with these time and time again, but we also see that the impact of extreme weather and also changing sea ice conditions is affecting how people are able to interact with these types of hazards. As I mentioned, increased vessel activity is also taking part in recent years, even so much as having cruise ships coming up in these areas. So there is also a new kind of vessel activity that we have not seen in recent years previously. And this also then puts an increased demand on both emergency managers and to the community in case these conditions do become hazardous and are dangerous. So the idea then is, how do we then support community knowledge? As I mentioned, these have been things that are not new to the communities, but the changing conditions are new. So we don't want to just impose the science on a community, but we want to make sure then that it's developed in a way that we can also learn from communities, see how they use this information, what are the gaps in knowledge that potential science can support, and then create new tools then that offer what people need in these events. So we take it then as a case study background, and we'll walk through this a bit, looking at an incident, a search rescue incident in particular that happened in 2017. It was a small motor-powered boat, and it went dead in the water in the middle of the night, around 10 miles north of Point Barrow, so off the shore essentially of Reykjavik. And this was among a drift ice pack. So as I was mentioning, this can cause damage to vessels. It can also cause motion where the vessel can get caught out to sea. And there was also a number of people on board, including children. So this became a really high priority event then to make sure that, these people could get out from where they were and safely back to shore. There was no communication with the vessel, so no GPS, no radio contact or anything. So this truly was a boat missing, and no one knew how to get to it. So this engaged then a group of volunteers, the North Slope Borough Search and Rescue Team, and the U.S. Coast Guard to try to conduct a search and rescue mission to find the missing vessel and the persons aboard. And this was a very novel also search and rescue mission, given that it actually engaged university scientists. So Reykjavik has a number of research scientists working up there, people that have experience on a number of different science tool development. And due to this missing communication element, this university was brought on board to see, okay, well, can we actually bring people and their knowledge into this kind of mission? So this actually presented a really unique opportunity to see how science can support these kind of really practical situations. And I'm happy to report that everyone was found safely. So there was no, luckily, any loss of life or anything like that, but it did take some time, of course. So nearly a day's worth of search and rescue. So let's then look at the science communication process in this kind of situation. And I want to at least have kind of the takeaway message first, so we keep that in the back of our mind. And that is, different stakeholders have different needs, and especially different data needs. So ultimately, when we talk about these things, either here in this presentation or thereafter, there cannot be a one-size-fits-all solution. So this is really pushing for this notion that we have to have tailored data products due to the really unique nature of these kind of events, and that even what works in one community may not work in another community. And in this case, we looked at different types of stakeholders, different types of people that would be involved in this kind of mission. We looked at the search and rescue operators, the subsistence hunters, so those that hunt whale and other types of marine mammals. And as I mentioned, university researchers and data providers, as well as the Coast Guard and other commercial boat operators. And we also identified that there's a number of different data products out there, and some of these are developed by the university system. So the International Arctic Buoy Program, for example, and this high resolution ice ocean modeling and simulation system. And we also had the Chukchi sea surface currents high frequency radar, as well as things that are not university products, like windy.com, that people often use to check weather conditions before they go out to sea. We also had a data product, which is the actual traditional and local knowledge, as I was mentioning, of the community. So people use that actually as a true data source in these types of situations, as well as other ice tracking drifters and search and rescue optimal planning systems used by, for example, the Coast Guard. And what we found in this kind of mission, where we were trying to support then the search and rescue efforts, was that what was used when we talked to these different stakeholders, what did you actually use when we're trying to conduct this mission? Things like, windy.com were things that people say, yes, we definitely looked at that first to see currents, weather conditions. Reykjavik has a large indigenous community, so the local knowledge of how ice moves and where it often moves was something that people relied on. And indirectly, and this is where I mean by in the graph here, these university products were used, not in the sense that people actually went to the product and looked it up and looked at the information. Rather, they talked to people that know the information and asked them to facilitate a bit this mediation effort. So I think what's important to show here is that even if people may not pick up a university product or a scientific tool and look at it, but having the connection with scientists is critical to make sure that information can be used. So what then, if we're looking at this from both a science production perspective and science communication perspective, what then do we need to do to ensure that there is this good environment where people can facilitate the knowledge transfer, knowledge use across different disciplines and in different ways? And we identified a number of different enabling and challenging factors. And often when we try to enter in, quote unquote, the market of information use, people need to be familiar both with the information and the information provider. So we have, for example, a researcher or a group of people that, especially at a local level in these small kind of remote communities, who they don't have the context for, probably they will not be the first kind of resource that people will go to. But having a long-standing collaboration, knowledge of such providers and so forth really plays a big role in the enabling factor. And this also plays into previous positive experiences. So again, if there's been this collaboration over time, it's been positive, people trust this information at the next point, then that's also something that enables people's use of it over time. So I think it's something to also think about. It's not just, we know it's good as scientists, we need to present it, but more that to develop that long-standing relationship first is more critical sometimes in providing the most and best available science. And there's also, in the case of, for example, agencies like the Coast Guard or NOAA or other kind of federal agencies, for example, in the US, but this applies to other countries around the world. Often there's a mandate to use a specific product. So that also kind of trumps any sort of other knowledge information use. And again, this all comes down to the reliability of the information. But also challenging factors, and these tie very closely with enabling ones, is often there's a lack of awareness. There's a lot of information being produced, but even like we are here today, not everyone is having access to this information, right? So having even increased awareness and knowledge about what's being produced and how it's being done is something that we have to think about from a science communication perspective. And also from a data perspective, people want up-to-date information. So especially in this context of remote areas, if it's not updated frequently enough, and if it's not done in a way that people feel like it's useful, it probably will not be used. And this also relates to inaccessibility. And this also is really typical if the information is not stored in a way that can be used offline, for example. Okay. And lastly, regarding procedural policies, so they can also be promoting and also excluding information use. So sometimes people cannot use information due to mandates for whatever reason set forth by their institutions. And lastly, also with a search and rescue context, real-time available data is really important. So something that takes multiple days to be validated, cross-pollinated, will not then be able to be applied in such a context. So I think the key takeaways to take from this case study is that there is a lot of different scientific and data information that can be used, especially in search and rescue, for example, but especially for the operators in these contexts, they don't know about them often enough. So those really apply for those developed by university and research institutions. So trying again to make sure that this collaboration is done well before an event like this is really important to make sure that this data can be used if and when necessary. And also the inaccessibility in remote areas is a really big problem. So refresh information, offline accessibility need to be considered when working in these remote communities. And lastly, especially when we talk about Arctic communities and other places with indigenous populations, finding a way to also integrate traditional local knowledge with science products also increases their relevance and likelihood to be used, and also shows how we can also respect and ensure that this knowledge is put forth as an equally important set of knowledge. Yes, so this is just a brief slide talking about the different number of people that supported this work. And if there's any questions also, we can take a pause here as well.
I have a question for you.
Yeah.
You mentioned lack of ability to access data, lack of knowledge of the data itself. Do you have recommendations from other scientists who want to share their data but just don't know how to do it? Just from your experience or observations?
Yeah, I think what often works is having depending on the community you're trying to target, and this again goes back that sometimes we have to work really small in order to get the information to be used, to try to understand what are the data needs, for example. So in this case, having data that can be downloaded and stored before you go offline is really important then. But it may not be as critical, for example, as Bokyo later in Juneau, which is in a city, and often this data connectivity isn't the same problem. So I think it's having kind of a conversation about what is the data and accessibility community faces, and then making sure then that product is tailored to that community's needs, and will be very different depending on each community. Yeah, good question, thanks. Yeah. Okay, well, we can transition then to our next section on glacial lake outburst floods. And we will first kind of take a step back then and hear a bit, since I've been talking a lot about agencies and emergency managers, and hear a bit the perspective of NOAA from the US and see how they've been working, especially in Alaska, on this topic. So this will be a virtual contribution by Dr. Jessie Cherry from NOAA, and we'll hear from her a few minutes online about their work in Alaska on this topic, especially.
Good afternoon. I'm Dr. Jessica Cherry, the National Ocean and Atmospheric Administration's Regional Climate Services Director for Alaska. Thank you for the invitation to speak today. I'm going to talk about NOAA's regional science communication before, during, and after cryospheric hazard events here in Alaska. The type of cryospheric hazards monitored by NOAA in Alaska include breakup ice jam flooding in the spring. They include glacial outburst flooding, typically in the summertime, and sea ice hazards in the Chukchi and Bering and Beaufort seas. And these type of hazards cover weather, water, and the climate continuum on different timescales. Before the hazardous event, NOAA strives to create informative websites to listen to community concerns and mitigate risk through data and informed decision making. We endeavor to incorporate local knowledge. We try to be consistent or actually engage in codified communication procedures during an emergency. We engage in coordination calls with local emergency managers. We have educational campaigns on, for example, social media and in the schools. And we strive to accomplish science and service to our constituents. Here's an example of an informative website about the Suicide Basin near Juneau, Alaska, which generated, due to its outburst, a very impactful flood here in the summer of 2023. During hazardous events, we work to schedule a cadence of communication between emergency managers, community leaders, and general public. For example, during an incident, we all might meet at 8 o'clock every morning. People know to expect that meeting, and all parties are there. We also utilize channels of communication that are appropriate to the community's preferences and infrastructure. For example, we might use radio in a community that doesn't have a local TV broadcast. Social media is widespread in many communities, but not everyone has broadband internet access. Town hall meetings are another in-person tool. After hazardous events, we work on communicating the analysis of the event and its impacts to the community and to emergency managers nationwide. We evaluate the services that NOAA provided. We reassess if we still understand the risks as being the same or if they've changed. We respect that events may have caused stress, grief, or trauma for the local community. And finally, long-term implications for major events could include permanent migration or resettlement outside of the community. and that can have long-term cultural impacts. Finally, teamwork, cultural awareness, and long-term partnerships are key to responding and preparing for these kind of events in Alaska. Thank you for listening. Feel free to reach out and contact me. Good day.
Great. So we heard then a bit from Jesse about then the role NOAA is playing, both as a science communicator and also as a community organizer in some ways about these topics. And I think this is something that we can expect moving forward more and more about scientists working on these types of initiatives, meaning that our role as scientists, looking at, for example, cryospheric hazards, among other things, doesn't mean just to provide the information, but to also provide a forum where we can discuss it with community members and to take it forward in such a way that we can create this long-lasting, as I mentioned, and as Jessie has highlighted in her presentation, relationship with communities to make sure that it's done on this iterative scale. So the next part then, we'll be looking at the case study of Juneau, Alaska. And we'll be looking first and foremost on the context of glacial lake outburst floods and how they impact Alaskan communities. We're just still waiting 1 second for the slide shift. So I'll provide the background then about, ice, water, and people in Alaska, looking especially at how glacial lake outburst floods impact different communities across the state. And we will then have a contribution by Dr. Erin Hood, who has been really living and working with glacial lake outburst floods in Juneau right after, to provide that firsthand knowledge and perspective of what it means to actually support these kind of emergency management responses. So Juneau provides a really interesting backdrop then to look at this GLOF event across the state, meaning that it's a place that experienced it time and time again. So we'll talk a bit more about what that means, but why it's actually such an important thing to research, apart from the novelty of the events that take place, is that several homes, tour operators, and public infrastructure are in the floodplain of and have been affected by time and time again these GLOF events. So therefore, there's a really strong interest in the community to capture and understand the impacts of GLOF events, and we really find a really fascinating cross-pollination and discussion between community members and scientists on this topic. I won't go into a ton of detail because I know Erin will probably be talking a lot about this too, but just to provide a backdrop is that the glacial lake outburst floods that happen come from Suicide Basin, which is adjacent then to Mendenhall Glacier. And Mendenhall Glacier is essentially right in the city. And this is something then that people can really see some way firsthand the dynamics of how this impacts them, given the proximity to both the city and the valley. So this is something to think about also when people live in the hazardous community. There's a much more higher level of both impact and concern regarding the changes over time. And what's also fascinating is this is also a relatively, in some ways, new phenomenon. Since 2011, we've been seeing nearly an annual release from Suicide Basin, which has been raising water levels in both the Mendenhall Lake and River area. In 2023, so this past summer, has actually been one of the most devastating GLOFs on record. So this is also something that isn't in some ways getting better with time, but actually we've been seeing much more drastic impacts over the last few years. But that's not the only place in Alaska. And I think this also provides a challenge in that not every community, as mentioned before, is the same. So we also have other places in Alaska that impact or are impacted by glacial lake outburst floods. And the Kenai Peninsula is another place also that sees and has these events happen. They impact a number of different communities, namely Seward, Clipper Landing, and the Kenai Keys. And we also found that people in those areas were interested to understand the science behind these GLOF events, because also Snow Glacier, which is the glacier that releases into the downstream area, is not as intensely monitored as Suicide Basin. So here we see that Snow Glacier is a bit further away than from the communities. So again, the lack of proximity and also kind of the out of sight, out of mind approach plays into why, again, people don't really relate to what they see when these global events occur, as we do in Juneau, for example. But also what is interesting regarding Snow Glacier is that this has been happening for a much longer time than Juneau. So we've been having the earliest reports of glacial-like outburst floods from Snow Glacier from as far back as 1949. And often these events result in nuisance flooding. So there's been also transport-related infrastructure damage to the railroad system around there too. And also there's a big fishing industry there as well. So a lot of cancellation of tours and other recreational operations. So we see raised water levels, and this also can impact communities in areas, as I mentioned, like Cooper Landing and Kenai Keys. So in this study, we looked at about the different also information products that are being used and that are available, and try to look at how people understood them, how they used them, and try to see if really there was some sort of, variance between these different communities and if and why that occurred. So these were mostly NOAA products. We looked at the National Weather Service hydrographs and inundation maps, and also their flood statement alerts. And we also looked at U.S. Geological Survey webcams. This was in Juneau, and also the water gauge that was set up there. And also in the case of the Kenai Keys and Kenai Peninsula, GLOFs, we looked at the civil air control photos to compare them a bit with kind of the webcam outputs from what we saw in Juneau. And this is a really fascinating study, as I was mentioning previously about the sea ice hazards and how there's a bit more kind of room to grow regarding community use of scientific products. In the case of the GLOFs in Alaska, at least these two, we saw that all 6 products were generally well understood by stakeholders. But the use of the data products varied widely among the different stakeholder groups. And there's often, again, this concept that we talked about previously in the presentation about information middlemen or middlewomen, having somebody there to translate the information for you, to call up and say, what do you think about this? Or can you interpret this for me? Really plays a big difference than in or if you use an information product. And we also saw that the role of social media plays a big role in information access. So the National Weather Service, for example, is quite active in publishing information on social media. But what we did find that was really fascinating is that most stakeholders actually went to the original data source. So that there is still kind of this like prioritization and validation of like knowledge too. People still want to make sure that they go to the trusted, as we talked about previously, source to understand the risks and so forth. So we also saw that, especially in the Juneau area, was that people were really concerned about what's the future of these events. They often talked about not feeling that they were getting enough information about the modeling and forecasting uncertainties. They really were curious about what would happen next year and the year after that. And as one stakeholder said, and this was a person living in Juneau, said, you can tell us, try to tell that scientists do not be afraid of talking about uncertainty as a way to make it seem like their products weren't as reliable or something. Rather, people really wanted to understand how reliable they were and to understand how that was interpreted by scientists. And they also wanted to know more about what trends were going to happen with these kind of events. Do we expect, from a science perspective, more events in the future, bigger, comparable, or smaller? So again, Erin will talk more about this, but there's a lot of community engagement, a lot of discussions with scientists. They have fireside chats, for example, at the local library, talking about these information. And I think this is a really fascinating way to see when something impacts the community so directly, there's also an appetite to learn more about it from a science perspective. What we also found was, again, the geographical risk. So on the Kenai, this is an area that typically has a lot of flooding in general. So people often do not think that the GLOF events were something unique compared to the typical flooding events. So that's also something to think about, is if an area already is exposed to hazard and risk, often these cryospheric hazards aren't so novel in the end after all. And also people's previous experiences. And this is something we see a lot in risk management literature in general. If people have survived something in the past and done it well, for example, then they feel a bit more elevated in their ability to handle this in the future, no matter if the risk is higher or smaller. So people looking at, for example, the National Weather Service products saw that, okay, it's not is expected to be a high water level as previous years, and it wouldn't be worse, for example, the 2016. So this one wasn't going to be quite as bad. So I think this kind of sets a nice stage then for the next discussion that we'll have with Dr. Erin Hood, who will be joining us then online. So thank you for that. Yeah, we can take a brief question now before we transition.
I was interested about this discussion about uncertainty you had with the stakeholders and what kind of uncertainty are they talking about? Is it like a verbal uncertainty? It might happen, it might not happen, or are they able to deal with, I don't know, probabilities, or what's the level of uncertainty discussions you have?
Yeah, I think especially this was related especially to the community in Juneau, and they've been looking at these hydrographs for year after year now for almost more than a decade. So they actually are quite well aware of what the information is saying. So they want to know a little bit more about the modeling uncertainty. So when they see a number, is this kind of a true number, or is this kind of a 20-30% likelihood? That kind of information we were asked to include in information to kind of understand what the forecast was predicting into what levels. Great. And Erin, right off to you then. You're muted though.
Hi, Erin. Great if you can unmute and go ahead with your slides. Let me know if you're having any technical issues with the chat, and we can try moving ahead.
There we go.
All right. Did that work? Can you hear me now?
Yes, we can hear you.
Okay. All right. I think I got it. Okay. And let me just go to full screen mode here. Dina, can you hear and see it okay now?
Yeah, we can hear you and see it. And if you would like to put it into present mode, that's also fine too.
Okay,
Once
it's
it gets
not.
fully
All right.
resharing.
See, and I had it in present mode on my end, but maybe
I would suggest unsharing and then resharing with it already in full screen. That should help pull up the slides with everything expanded.
okay. All right, let me do that. All right, stop. All right. Okay, full. Although if I put it in full screen, then I can't switch back to, and I can't switch back to the screen to add it to share screen.
Just do whatever easiest for you then. We'll be able to see it in any case.
You might be able to swipe with the fingers
Okay.
across.
Say it again.
Depending if you're using a Mac or Dell, you can either swipe with 3 fingers across the trackpad, or there might be a command to shift tabs. So if you're full screen, you can shift to a different tab, such as your browser.
Okay.
You can try Control Tab as well, hitting those two.
Try that again real quick. All right, I hit Control Tab and it doesn't seem to. So I'm in full screen, but I'm not sharing. And if I hit Control Tab, doesn't.
Yeah. You can just do escape then, and that probably will get it out of present mode.
Yes. So if I go, I can make this bigger, although some of it's animated. So I can't hit present mode once I start sharing. Let's see. Window. Yeah, I tried Control Tab, and that wasn't. So this doesn't. You can't see that in full screen.
You can just share it in any case at this point, and it'll be fine. We'll be able to, yeah, we'll be able to see it. So just do work.
Okay, I'll just start.
Yeah.
Going at this point. Okay, so I just want to start by quickly acknowledging my co-author on this, who's Aaron Jacobs at the National Weather Service. So as Dina mentioned, I'm going to be talking about glacier lake outburst floods. And in this case, the mechanism of the glacier lake outburst flood that we have in Juneau is that there's a retreating tributary glacier. If you can see this red arrow here, that leaves a void space along the main Mendenhall Glacier. And this void space is an overdeepened basin that can fill with water, and the main Mendenhall Glacier then acts as a dam. Each summer since 2011, which was the first flood that we had, this space would fill up with water, and when it fills to a certain point, the hydrostatic pressure actually lifts the main glacier up, and then the water drains out underneath the glacier. Oops. Okay, so the name, we recently changed the name. It was Suicide Basin, but we worked with some local indigenous people to try to get a more historically relevant name. So we're calling it now Kookskadi, but that was previously known as Suicide Basin. And this slide just orients you to where it is. And Dina kind of showed an overview of this, but basically the basin is just a little ways up the Mendenhall Glacier, above Mendenhall Lake, and then Mendenhall River, which drains the lake, runs through the largest population center in Juneau, below the lake there. This next slide is not going to work. Animation, but basically here's an overview of it, and you can see this glacier, the Kooks Glacier, which is retreated up out of the basin. And so there's this overdeepened basin. The main Mendenhall Glacier is sealing off the basin, and this is the source of the floods. And so if we go to the back of the basin here, so we're looking out toward the main glacier, you can see the ice flow is down glacier, and then the water drainage. So this basin, this is all full of remnant ice that was left over from the previous Kooks Glacier that was there. So the water fills up in this basin, and then at some point it drains underneath the ice dam and down into Mendenhall Lake. We have a wide variety of field instrumentation there. One of the main instruments we use is drones, which we use for mapping, and I'll show some examples of that. We also have time-lapse cameras, water level sensors, things like that. And again, in the background, this is still showing the basin that fills up with water. As Dina mentioned, the flood has been going on since 2011. There have been there's been a lot of variability in the size of the floods between years, and some years we've had some fairly substantial nuisance flooding, but nothing that's really done a lot of damage. So you can see here roads and campgrounds being flooded and erosion going on in people's yards downstream from the glacier, as well as some flooding into neighborhoods and into basements and things like that. So previous to 2023, there was nuisance flooding, but there was really no substantial damage from this event. That changed this year. And I just want to show you a time lapse. So this is one of the time lapse cameras that's looking into the basin, and it gives you a sense for how the basin fills up. So it's showing one photo a day during the summer of 2023. So here we're in June, July. So the basin is filling up with water. And then in early August, you're going to see the rapid drainage event that occurred. And so this is where we're monitoring it. And then right here, the drainage occurred. So, and then there's a few after that, there's a few minor events where it refilled partially and drained as well. But the main event occurred there in early August, which you can see all of that water draining out of the basin in the time lapse. Not sure if this video will work, not in presenter mode here. But you can basically see what this was as a video taken from a drone of some of the downstream erosion. And we had about 9 structures that were either heavily damaged or completely fell into the river. You can see this house, the majority of the house fell into the river, was swept downstream. And you can also see there's a condominium complex that was heavily undercut there to the point where it had to be abandoned so that it could be rebuilt underneath there. So a real kind of step change this year in terms of the amount of damage that occurred. As I mentioned, we use drones up here to do mapping of the basin. And so we fly drones over the basin, and we take more than 1,000 photographs. We use those photographs in a process called structure for motion, which essentially just means if you have a moving camera, you can create a 3D image of the basin. And so in the upper right-hand corner here, you can see the 3D imagery that we collected, and then we can make a 3D model from that. And that's really useful because it allows us to calculate the volume of water stored in the basin. So we can use it, do a drone survey before the flood. So this is in July, and after the flood in early August. And then we can difference those two maps that we created and calculate the amount of water stored. And in this case, that was about 50 million cubic meters of water that drained out during that flood in early August of 2023. It's also useful for understanding how the basin is evolving over time. And looking in the photo there, you can see out toward the main glacier where there's calving and there's erosion and melting of the ice. And so this has the potential to increase the storage capacity of the basin. This elevation model that we created with the drone right after the flood is also extremely useful, because the reason that the flood was so large this year was that we had a much deeper drainage event than we've had in the past. In the past, it would drain part way and then it would stop for whatever reason. And this year it drained much further down. And so now we have a map of this. And that map allows us to create what's called an elevation storage curve, which we can use to predict the potential volume and peak of the flood. And so in this case, if we know the water elevation, we can use that on this graph to figure out the amount of water that's being stored. Here they're showing storage in acre feet, which is a US unit. And so you can then use that volume to predict what the maximum flood might be associated with the drainage. So it's a really, although this was a very unexpected year in terms of the flood, it turned out to be useful in the sense that we now have a much better sense of the upper limit. To compare the hydrographs, so these are all of the floods that we've experienced since 2011, and you can see 2023 is in this yellow color, and it was about 50% again as big as any flood that we had seen previously, and that really highlighted the challenge with the response this year is that this curve right here, this sort of gray envelope, shows the largest 5 events that we'd seen previously, and those were the ones that were basically being used to model the event this year. But because the event this year was fundamentally different in terms of the amount of drainage, the model didn't work and pretty vastly underpredicted what the flood peak was going to be. So again, there was a lot of surprise, and the damage that happened was really unexpected because of that. But now moving forward, we have a lot better information. It also highlights just the challenge with flood statistics when you have cryospheric hazards. And so this is showing the stream gauge data on the Mendenhall River, the peak flow for each year. This was usually 15,000 cubic feet per second is a really high peak flow, but you can see since 2011, when the glacier outburst flood started, that this kind of a peak flow has become much more common. And then in 2023, we went way above that. We got up to 26,000 CFS, cubic feet per second. And so again, it's been a really dramatic change in the flood statistics associated with this basin. And one other big concern is that one of the other hazards that we have in Juneau is we have a lot of very large precipitation events. And so these have the potential to become additive in the sense that if we have a glacier outburst flood, and then this is just taking what looks like a small flood on August 13th here, if we took this rainfall driven flood that happened here and made it occur coincident with the glacier outburst flood, we would have had a peak flow that was close to 30,000 cubic feet per second and done a lot more damage. And so if we have something like an atmospheric river, that would really add to the hazard that occurs. I'm going to skip down to here. And this is just to help understand how the hazard itself is evolving. So again, this is a satellite image of this basin that stores the water. And so there's a couple different dynamics going on. One is that the ice in the basin is melting. It used to be very continuous cover of ice and we could walk out across. Now it's melting. The more ice in the basin that melts, the more liquid water it can hold, which can create, again, a larger flood. At the same time, the main glacier up here, which is the dam that's holding the water back, is thinning and shrinking. And so that means that the dam is getting lower. So in that sense, it can hold less water into the future. To communicate the hazard with this, we created a sort of real-time monitoring page. And so this is available to the general public, and they can watch the real-time imagery from the time-lapse cameras, and they can see the basin filling up and predictions about the type of flood that might occur. And really, we use this as an early warning system for residents of Juneau, because as the basin fills, once we start to see the water level drop, we have about a day and a half until the peak of the flood. So we have a good amount of time to warn people about the impending flood, because the flood starts out slowly and then picks up steam very rapidly as the water sort of erodes its way under the glacier and widens the drainage channel. We can also look, Dina mentioned the snow glacier on the Kenai Peninsula. And this graph, the blue dots in light blue and dark blue are just showing the peak flows associated with different glacier outburst floods. And this just sort of highlights some of the unknowability of these type of events, that they vary really dramatically year to year. And so this one has been on average increasing in volume, the flood event. If you go back decades, this graph goes back to the 1950s, but there's a lot of interannual variability, and that makes it very hard to communicate that you could have potential for large floods, but some years they just won't occur because the drainage dynamics don't evolve rapidly. And then just to finish up here, a lot of what happens in the future with this hazard will be dependent on the future of the Mendenhall Glacier itself, which is acting as the dam. And so you can see this was some modeling that we did to look at the future of the glacier. And so here's kind of the present day extent of the glacier shown in the going down to the lake here. And then if we look at retreat in the future, if we assume a low level of retreat, the dam will still be in place by 2050. If we assume a higher level of retreat because of warming, the glacier will have retreated up by where the basin opening is. And so there will no longer be an outburst flood because it's not blocking the opening of the basin anymore by 2050 in that scenario. So just to finish up here, there are a lot of different people in Juneau and around other parts of Alaska who have helped out with this. And then a lot of different agencies that have provided funding to support our research on the Glacier Lake outburst flood. And with that, I'd be happy to take any questions.
Thank you, Aaron. Yeah, any questions? Well, we appreciate, you giving us the first-hand perspective. Also for myself, I've been working on these floods too for almost, on and off for a decade now. And it's, just fascinating to see. It's also really unfortunate to see what happened this past summer, but it shows really the important work that needs to happen to make sure that the science is on really the cutting edge, to make sure that we monitor these days so we can be on, the upside for any future events like this to happen. So thanks again for joining in at a very, very early hour. We appreciate you having you here in this presentation. So
all right,
wonderful.
Thank you.
Yeah, thanks. Okay, well, we'll wrap up then with the last section. And I think then just to talk about kind of the key takeaways from this presentation today. Great. So what is the outlook? We talked about a number of different hazards that are coming from our changing cryosphere, how they're impacting community in different ways, and ultimately the role of scientists in this process to support communities to be better prepared, and also to learn from communities, as we saw from the Juneau example, and also from the Utqiagvik example, is that the communities that have been facing such hazards time and time again have a lot of knowledge to also offer. So it's not to say that the science is higher or the community knowledge is higher, but it's really more the combination of the two to ensure that we can create well-adopted strategies for communities to be successful in their emergency management. And I think the takeaway to take from this is there's going to be a number of different facets that we have to focus on to ensure that cryospheric hazard management is done in a good way under this especially changing climate concept that we're facing. What we know won't be the same next year or even in 5 or 10 years. So it really requires a lot of updating and keeping on the upside of information, knowledge, and creation. And therefore, we need better forecasting, of course. So there is truly a need for more robust science to come out of this, both from meteorological monitoring agencies and also other research and scientific institutions. So there is a large role for scientists to play to make sure that hazard management continues to be on the forefront of development. But also, as I've been mentioning throughout the presentation today, we need increased collaboration, of course. So it's just not only with scientists and community members, but also with emergency responders, with policymakers, and most importantly, the local effective community. And this is the point about policymakers, is who funds this ultimately, right? So who creates the burden basically of trying to make sure that this is done in a way that's sustainable, that it's done in a way that ensures that the information is at the right level at every given point in time. So bringing this up to high level policymakers, decision makers is really critical to make sure that there is sustained use both of the science, but also of the facilitation between community and scientists in the years to come. And also early warning systems, as we saw a bit with Aaron had showed from the Juno example, is that we need to also have a way to monitor these events before they happen and not just act reactively, of course, too. So this is something that needs to be done on a large scale as possible, and also to create standard operating procedures for emergency response. So these are things that we can also do across regions, across different contexts. They don't have to be so local specific in that way, but in that sense, we can also try to create a more globalized approach to be able to respond if and when these events occur. But also there is a big gap from this risk and decision framework. So what are the actions that have to take? And especially when we deal with a large uncertainty. And what we saw last summer in Juno really shows that, is that we've been used to a bit this nuisance flooding and okay, halfway draining, as Aaron was saying, and it's okay, it's devastating, but not really true devastating in the way that we saw this summer. So we have to be able to also value the risk in a way that even if we don't have a concrete understanding of the potential outcomes, what are the different frameworks to take into consideration? And this is something that really does kick in when we have these large uncertainties related to cryospheric hazards. So this is also opening up a new way of collaboration. Me and Medina actually just published a paper recently on this topic of decision-making under uncertainty with regarding to different types of cryospheric hazards. And this actually opens up a whole other body of literature and knowledge that we can bring into play. And how do you actually look at long-term forecasts when you have, in some ways, big model uncertainties that can either make or break the model in some way? So this is something that we can really also bring forth new knowledge and new information to look at this not as a barrier, but also as a way to innovate better our understanding of uncertainty. And to also see how we, again, can communicate this to stakeholders so they can use this information in a way to make decisions, even if they don't have the best possible information. So that's also what we're operating under. We have to create policies and take decisions, even if we don't know exactly what's going to happen. And we can't not do something because we don't have information. So I think that's that way we can have some role as a university then to support both agency needs, practitioners to support these gaps. So in some ways, as we saw from the examples from Alaska, the university can provide agility and flexibility where often there are standard operating procedures that, agencies don't have. And this can be a nice way then to get the best of both worlds by these types of collaborations. So lastly, I wanted to share also this diagram as some food for thought, is that also the way that stakeholders operate is changing over time. Traditionally in the past, as you see on the left, there was a provider to user relationship, pretty linear approach where an agency or an institution would publish something and someone would use that information. But now we're also seeing, again, as we saw from these examples in Alaska, that providers and users are kind of sharing the knowledge together and working together to create new information. But also, arguably, we're seeing more and more user-to-user knowledge sharing as well, too. So people that are also sharing, as I mentioned, from social media, from their own local knowledge, information together. This is also another body of information that we have to also take into play and not only look at facts and science as one way that people take decisions, but also their own personal experiences and experiences from elsewhere that they also take into account. So if we ignore this kind of user-to-user knowledge, we also lose a big part of the information landscape out there. So I think to close then, we really want to see more and more interdisciplinary, multidisciplinary, ultimately transdisciplinary research looking at these topics. And different methodologies in different fields can really support each other to be applied to create the best possible information moving forward. And we always talk about informed decision making, but I think it's also important to note that sometimes, just because it's informed doesn't mean that it's always good. And this always comes back then to making sure that we have to incorporate the community needs first and foremost. So a good decision often has to make sure that it reflects reality on the ground. Thank you very much. Great. Unless if there's any other questions, yeah, please.
So it's last week, negotiators wrapping up everything and finalized decisions. Do you have any outcomes that you're really looking for in the context of the station? Things that you could be both useful or even on a small scale. You just like to see how they in the near future.
Absolutely. I'll just rephrase it a bit for those online. But yeah, it's last week of COP, and what are kind of the expectations to, or that we hope to see come out of COP in light of what we've been discussing today? And I think that's a really great question, given that it's such a complex problem that we're facing, which is what we're dealing with and why there's so many people here at COP to discuss these topics. But I think largely to an extent, we still are very siloed in our approach. We take comfort in working with what we know best. And I think what I would love to see moving forward as what we had done with this work is to try to start to push that boundary a bit and to say, well, what can we really do differently? And what potentially, as I mentioned, informed decisions aren't always good if we don't have the full context. So in order to kind of make sure that we level out that playing field, to make sure that everyone who would be affected by these events in any shape or form are part of the table and really have an equal voice. So I think it requires also a very different framework of looking at who is affected and who gets a seat at the table, and to make sure that that gets more and more presented in the years to come. Yeah, thank you. Great, thanks so much. Yeah, bye-bye.